Why does absolute value sometimes give two answers and sometimes none? If you understand what absolute value really means, these problems become automatic. Absolute value means distance from 0 on the number line. For instance, if we have absolute value of x equals 5, the translation is what numbers are 5 units from 0? So if we look at our number line, -5 is 5 units from 0, and +5 is also 5 units from 0. So in this case, x could be equal to 5 or x could be equal to -5. But distance is always positive. That's the key idea. There's no such thing as a negative distance. And this single concept unlocks every absolute value problem you'll ever face. Here's the golden rule. Every absolute value equation follows one master rule. Absolute value of A equals B. If B is positive, you'll split into two cases. A equals B or A equals -B. That's two possible solutions. If B equals 0, there's only one case. A will be equal 0, and there is exactly one solution. If B is negative, as you know, distance cannot be negative, there is no solution, so you can just stop immediately. Here's our first example. We want to solve the equation absolute value of x minus 3 equals 4. So since 4 is positive, we'll split into two cases. First, solving for x minus 3 equals 4. If you add 3 on both sides, x is equal to 7. The second case, solving for x minus 3 equals -4. If you add 3 on both sides, x equals -1. And both solutions check out when plugged back into our original equation. Absolute value of x minus 3 equals 4. When extra terms surround the absolute value, isolate it before splitting. For instance, given the equation absolute value of x minus 3 plus 3 equals 4. First, we'll subtract 3 from both sides. So absolute value of x minus 3 is therefore equal to 1. Now we can split and solve. Case number 1, let x minus 3 equals 1. If you add 3 on both sides, x will be equal to 4. And case number 2, let x minus 3 be equal to -1. And if you add 3 on both sides, x will be equal to 2. So our two solutions will therefore be x equals 4 or x equals 2. Always isolate the absolute value expression on one side before applying the golden rule. Splitting too early is one of the most common mistakes. Here's the next example. We want to solve the equation absolute value of 2x plus 1 equals -3. Can distance equal -3? No. Absolute value measures distance, and distance is never negative. The moment you see the equation equals a negative number, you can stop. There's no solution because no value of x will ever make this equation true. Don't waste time splitting, just recognize the impossibility and move on. When a coefficient multiplies the absolute value, divide it away first. For instance, if you have 2 times absolute value of x minus 5 equals 8, first you'll need to isolate. So divide both sides by 2 so that you have the absolute value term on one side of the equation. So this becomes absolute value of x minus 5 equals 4. Then we can split it. Let x minus 5 equals +4 and x minus 5 equals -4. And then you can solve for each. So x will either be equal to 9 or x is equal to 1. The pattern is always the same. Isolate, split, and solve. And of course, always check your solutions. Here are the common mistakes to avoid. Forgetting the negative case. Always write both equations. Missing one means losing a valid solution. Splitting before isolating. You must get the absolute value term alone on one side first. Extra terms will give you wrong answers. Distributing the absolute value. absolute value of x plus 2 is not equal to absolute value of x plus 2. Absolute value does not distribute like multiplication. And finally, ignoring no solution. If the isolated absolute value equals a negative number, stop, because there is no solution. Here's your challenge for today. Solve this equation: absolute value of 3x minus 2 equals 5. Apply the golden rule, split it into 2 cases, and solve each. And you can pause the video before checking the solution. So here's the first case. Let 3x minus 2 equals 5. In order to solve, you'll add 2 on both sides, so 3x equals 7. And finally, divide both sides by 3, x equals 7/3. For the second case, let 3x minus 2 equals negative 5. If you add 2 from both sides, 3x equals negative 3. And solving for x, divide both sides by 3, x equals negative 1. So here are your two solutions, either x equals 7/3 and x equals negative 1. If we want to look at this graphically, for instance, if you have y equals absolute value of x minus 3, it will form a V shape with its vertex at the point 3, 0 right here. So if you want to solve absolute value of x minus 3 equals 4, you need to ask yourself, where does the graph intersect the horizontal line y equals 4? So if we look at here, we can see that y equals 4 when x equals negative 1, and y equals 4 right here when x equals 7. So the line crosses the V at 2 points. That's why we get 2 answers. If ever the line is below the vertex, anywhere here, there will be no solution because it never touches the V. Here's the complete method at a glance. Every absolute value equation follows the same reliable pattern. Whether the expression is inside is simple or complex, the method never changes. Isolate, check, split, and then solve. Absolute value isn't scary. It just means distance. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.